atomic number. Atomic number is the number of protons present in an element. So actually these protons present in nucleus, you know now the number of protons present in an atom of the nucleus is called the atomic number. This is equal to the number of electrons present in energy levels as well of that element. We can say atomic number is equal to number of protons again equals to number of electrons present in element. That is it. And the other thing is the atomic number of an element is a unique characteristic of that element. So this is very important when we are developing a periodic table or when we are building up a periodic table. Other topic is the mass number. Mass number is the sum of the number of protons and neutrons in the nucleus of an atom. So mass number equals number of protons plus number of neutrons. That is it. You need to know how to indicate these atomic number and mass number related to the element. So on the left hand side of the symbol of the relevant element, the atomic number is written at the bottom and the mass number at the top. That is it. In the left side, we are writing this atomic number and mass number. And the other thing is, bottom, we are writing atomic number. Top, we are writing mass number. We are talking about the atoms. When we are talking about the atoms, the difference between the mass number and the atomic number gives the number of neutrons in the atom. This is very important because there are simple calculations regarding this number of protons, number of neutrons and number of electrons. So try to solve these problems. And the other thing is about the electronic configuration. Electronic configuration is the arrangement of electrons separately in energy levels. If you can write the number of electrons present in each energy level separately, that is the electronic configuration. There are electrons in energy levels, first, second, third, so on. So you have to write the number of electrons present in first energy level, comma, second energy level, comma, third energy level, likewise. And it's very simple if you can have a periodic table with you. So we are going to learn about the periodic table. This modern periodic table has introduced first by Dmitri Mendeleev, scientist. And this modern periodic table is based on the atomic number and the electronic configuration of elements. In your level, there is only 20 elements present in your periodic table, but altogether there are more than hundreds of elements present in the periodic table. In the periodic table, there are periods and groups. What are the periods? What are the groups? Horizontal rows are called periods, while vertical columns are known as groups. Very simple. And there are 8 groups and 4 periods in your level, in your periodic table. There's a special thing regarding the periods and groups. Remember these things. If you can see the period number, this period number resembles to the number of energy levels present in the element. And the other thing is group number. This group number is equals to the number of electrons present in last energy level. These things are very important. How do you put an atom to the suitable period or group? Then you have to calculate the number of energy levels present in the element and number of electrons present in the last energy level of the element. So you can easily place that element into the suitable square of the periodic table according to the last number of the electronic configuration and number of energy levels. Think about the aluminium. If you consider about the aluminium has the atomic number of 13. Its electronic configuration can be written as 2, 8, 3. It's very simple. So you can see there are 3 energy levels. 2, 8, 3 means we are writing 3 numbers separately. That means there are 3 energy levels. So this aluminium belongs to 3rd period of the periodic table. I told you that the number of energy levels present in an element resembles to the period number. And the other thing is 3 is the last number of electronic configuration of aluminium. That means it has 3 electrons in the last energy level. So this number of electrons present in the last energy level is equal to the group number. So aluminium belongs to group number 3. Likewise, we can place all the elements into the suitable square of the periodic table. And next one is about the isotopes. Isotopes, the atoms with different mass numbers in the same element are known as isotopes of that element. So isotopes have same atomic number and different mass numbers. Reason for this different mass number is the presence of different amount of neutrons in that element. So if you can remember about the isotopes of hydrogen, there are 3 isotopes of hydrogen. They are called protium, deuterium and tritium. Protium H11, deuterium H12, tritium H13. So all of these isotopes have same atomic number but different mass numbers. This is because of the having different number of neutrons in nucleus. And the next topic is patterns seen in the periodic table. There are 2 patterns we are discussing in this syllabus: first ionization energy and electronegativity. First ionization energy. What is the definition for first ionization energy? The amount of energy, that means the minimum amount of energy that required to remove an electron from a gaseous neutral atom to produce gaseous unipositive ion is called the first ionization energy of an element. So this first ionization value is different from element to element. So we can simply plot these values on a graph paper and check the pattern. If you can see this picture in the tube, you can easily understand there is a special pattern seen in the first ionization energies of elements. We are discussing about the first 20 elements of the periodic table. In this graph, you can see the first group elements like hydrogen, lithium, sodium, potassium. They have the minimum value for first ionization energy. And the elements like helium, neon, argon, they are known as noble gases. They have the highest values for first ionization energy. And if you talk about the lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, second period elements, you can see there's a zigzag pattern of this first ionization energy. This is easy to understand, easy to memorize if you can see that zigzag pattern of this first ionization energy. So in the second period and also in the third period, the variation of first ionization energy shows the same pattern, but it is different from values. But if you can understand the pattern, it helps to memorize these things. So highest first ionization energy shows by helium, while minimum first ionization energy shows by potassium. You need to memorize this graph of first ionization energy, because this is the key point that may be in your exam questions. And the other thing is about the electronegativity. Electronegativity means the ability of an atom to attract electrons of a bond towards itself when it is bonded to an atom of another element. I think there is a covalent bond between 2 atoms, A and B, as shown in the picture. So there is a bond between A and B elements or atoms. So there is a pair of electrons in between A and B atoms. Electron pair can be moved towards the A if the electronegativity of A is high. And the other thing is, if the electronegativity of B is high, this electron pair moves towards the B. That's comparative. There may be equal electronegativities and different electronegativities. So this bonded electron pair may be moving towards A or B according to the electronegativity values. And there's a scale called the Pollen scale to measure the electronegativities of different elements. According to the Pollen scale, fluorine is considered the element of highest electronegativity. And the other special of this Pollen scale is that it does not assign electronegativity values to noble gases. And again, you can see this graph that shows the electronegativities of elements, first 20 elements of the periodic table. But there is no noble gases included into this graph, because in this Pollen scale, we are not considering about the electronegativities of noble gases. Here you can see the minimum values of electronegativity. Takes the first group element like lithium, sodium, potassium. This is same as to the first ionization energy graph, but the variation is different. There is no zigzag pattern here. Linearly, it increases from left to right of the periodic table. I will move to the key points regarding first ionization energy and electronegativities. If you consider first ionization energy increases from left to right of the periodic table as a zigzag pattern. And the other thing is electronegativity. Electronegativity increases when you move from left to right of the period linearly. And the other thing is down the group. Electronegativity of elements decreases down the group. And first ionization energy also decreases down the group